Alright guys, so I'm going to be showing you how the plasma pump works in a little bit more detail than I probably have before. So using the CAD assembly, things aren't constrained completely how I want them, but it should be good enough. So let's get started. Basically, this is the magazine. It holds about 8 rounds right now, uses a AR-15 mag spring just for ease because they're so cheap, but I'll have some jigs for that soon. So the bolt has to be open to insert the magazine. The feed lips can't go around the bolt basically, so that's one problem I don't like. I'm not too sure how to easily fix it though, but not too big of a problem for a 3D printed gun. So the pump is connected to the bolt here through these op rods. They're just 1/4 inch threaded rod. So you pull the pump back. Let's see. Let's put it in. All right, yeah. Let's go into battery here. So the bolt pushes the cartridge into the chamber, and basically there are these two probes here which ignite the powder. Go through, let's see, so there's an ignition unit in here with two ignition leads. One of the ignition leads goes up to this bolt spring guide connected to the screw. The washer should be pushed up so it's touching the screw, and then the bolt spring connects these two washers and conducts electricity through them. And then there's a wire that goes around and connects to this screw here, which touches the firing pin. If you're assembling this gun, take note that this screw here can't be too tight, otherwise it lifts up the stabilizer. So you just need it barely contacting the firing pin. So that conducts electricity through the firing pin. And the chamber probe, basically it goes from the ignition unit in the stock, outside of the stock here, up and around connecting to this screw here. Now let's go back to the half section view while I'm doing that. Also, that top screw that's going into the chamber, this is actually two different screws. One that stops right about there, and the other screw in the receiver that just comes down and contacts that, and that makes the barrel removable. So now we got the two probes and the case in position. This is a resin 3D printed case. I was doing some experiments with conductive resin. Turns out it's not conductive enough to get rid of these air gaps. So you need the air gaps for the arc to conduct through here. Otherwise, it has a tendency to arc. Basically, it goes around here, a much longer path, so it's going to prefer to go through there, but if this is completely sealed, it's not going to. So that would cause a misfire, so the gaps are important there. I usually seal these gaps up with Elmer's glue, alcohol to thin it out, and graphite for conductivity. You really just need a little bit of Elmer's glue. And that seals it up perfectly, makes it waterproof, and prevents chain fires. Chain fire happens if you fire it without the locking lug in position. So the recoil is going to push this out, usually stops right about there. It's not too dangerous to the shooter, but the gas will escape into the magazine here. And if the air gaps aren't sealed, as you can see, there's a direct path for the chamber to ignite the cartridges. I've had that happen with unsealed cases, and it did blow up the magazine, so I added these vent holes, which should prevent that from happening even if you do get a chain fire inside the magazine. But overall, it's not that dangerous. It's just plastic and not too high of a charge in these rounds. So don't worry about that too much. Just make sure it's locked up and you got your bullets sealed. I should say cases sealed. So now we got this in battery. Now we'll move on to the locking. So this is solenoid locked. It uses this, a solenoid is just an electromagnet. Basically you got the battery here, and between the battery, I'll just say, so to power the solenoid, you just flip a switch on the pump here, and when you do that, it unlocks, basically runs current through the solenoid and pulls it down through magnetic force. So that's only to unlock the bolt. So now that we're the bolt's in position, it's just going to lock up via spring force. There's a spring between the solenoid and the 3D printed connection piece here, and that pushes it up into, I guess, into battery. And then this bolt lock button rides on top of the locking lug. It's got a little magnet there, and that ensures it shows the correct position of the locking lug. So you can use this button to visually check if it is locked or not. You can also use it if battery dies or something, you can just push it down to unlock the bolt. So now let's get into the actual firing. Oh yeah, I should add the steel. This is a steel locking lug, 3/8 of an inch, and then this is a rectangular tube, which I got from Home Depot and cut down to the correct size. This is the exact dimensions of the locking lug, so it acts perfectly as some reinforcement and distributes the force in this bolt stabilizer. Alright, so now down to firing. So we have the firing pin and the chamber. The arc should pass from the firing pin to the chamber probe, go through those, and ignite any powder between the two probes. I'm not too sure. There's two mechanisms that could be igniting the powder. Either it is the arc itself creating a plasma, which pretty much all arcs do, but it generates a really hot plasma. And that could be igniting the powder itself, but black powder usually has graphite coating around it, which might conduct the arc around the grains of black powder, which it could potentially heat up enough to ignite it, but I'm not too sure. The other mechanism is just the firing pin getting superheated due to the arc of electricity, basically, and that superheated firing pin might be igniting the powder as well. But either way, it works. Whether it's, one way or another, it's just an arc igniting it. Physicists can tell you more, I guess. So once the powder is ignited, you'll see that the chamber is oversized here. This allows the resin or the case to expand and shatter. Different materials are going to work better. The resin will shatter a lot more reliably than an FDM printed casing, but you might be able to find a better material with FDM too. But yeah, that requires experimentation. So, all right, so back at it again. My mic died after 10 minutes, I guess. So we're going to start back up with the case igniting. Let's move that back in there. So I should say, actually, before the case ignites, it headspaces on the barrel here. The case headspaces on the barrel. That is something that I want to change because that gets worn down after about 20 rounds or so, and you have to print extended cases. It just involves printing different cases. Not too big of a deal, but it's going to continue to wear down. So yeah, that's something I need to work on. But so anyway, the arc ignites the powder as I went into black magic. It ignites the powder. The case expands into the chamber. The chamber is larger than the elongation at break, which is how much you can stretch a material before it breaks. So basically the case stretches farther, too far, and it breaks in the chamber. It breaks apart into little pieces. Bullet goes down the barrel, and the pieces of the case should travel behind the bullet. The bullet is rifled with the same rifling as the barrel. It's octagonal rifling, very similar to Whitworth rifling from the 1800s. He did something similar, but with metal, obviously. And that could get good. I think it could hit man-sized targets out to 500 yards in the 1800s. Don't really know how that'll translate to a 3D printed barrel and 3D printed jackets, but shit, it's a pretty good goal to hit at least. So let's see. And the rifling in the barrel is 3D printed, and it has a steel reinforcement tube around it. That basically compresses the rifling, or I should say, when it fires, the rifling is gonna try to expand and it'll hit up against the steel reinforcement, and that'll compress it. that compression is a lot stronger than, trying to pull a material apart, which is tensile strength. And so the compression strength of material is usually much higher than the tensile strength. So this utilizes that compressive strength in the barrel. The manufacturers don't really give out the compressive strength, so that's something that I'm going to be doing research on with my school next semester to hopefully get some solid values. But as it stands right now, the value should be at least lower than the pressure value that the steel pipe bursts at, so the rifling should shatter and release pressure before the steel pipe bursts. So now we'll get into unlocking the bolt, which is pretty easy. It's just the pump here has a trigger on it that brings current to the solenoid and magnetizes it. The magnet pulls a plunger down, which unlocks it. And let's see, other than that, that's pretty much it. It's got some threads on the barrel, which I need to work on a threaded muzzle for that. And it is a 16-inch barrel. It's actually like 16.25 inches. So a little on the short end, but still legal. Make sure if, the tip breaks or anything, throw it out. Don't want to be committing felonies. Let's see, other than that, yeah, I think this is pretty much it. Completely 3D printed besides the electronics. There's the op rods here. I can't remember if I explained the heat shrink tubing on the op rods, but if I didn't just read the instructions, you need some heat shrink tubing. Probably don't actually need it, but it helps. Other than that, yeah, it goes back. Next round goes up and it goes in, cycles again. Bang. I'll pull up the full view here. Feel like I'm missing something, but yeah, that should be about it. Thanks for watching.